This is what Matt, your course description looks like, right? It is expected that by the time I said the whole thing is over, people will be able to know a lot about what is showing on your screen. This is called your course description or your course content. That means you're supposed to know what is all about function of a complex variable and the properties and also consequences of what analysis and then the techniques, and then also we're going to know much about the complex integration, conformal transformation, and so on and so forth. And then the next thing we're going to do is we're going to look at method of ordinary differential equation, either in closed form and the exact solution. Then we'll move to local and global analysis of some boundary problems using layer theory. All these ones, they are not we're not treated at undergraduate. Then WKB also include some eigen value of Schrodinger type, Schrodinger equation, and then we'll also look at some harmonic oscillators. Then we'll just talk about, I will introduce a partial differential equation, which is very simple. The method of characteristics for solving first order partial differential equations. Yeah, at this point, I believe that you are already soaked in mathematical method. Then the concept of shock waves and application. We're going to do everything, and then we're going to do the transform method application to what to the solution of. We talk about boundary value problems, whether it's initial or whatever. This is all about the course description, and then what is expected of you for this first aspect, which we're going to talk is when we're talking about function of complex variables and the properties. And then we'll talk about techniques, we'll talk about analyticity. Um, this is everything that we'll be treating under that topic. Complex function. Under complex function, we'll be talking about the Cauchy-Riemann equation, the conformal mapping, the standard complex functions, basic complex integration, the Cauchy's theory, singularities, and residues. Now, I would just talk a little bit about complex function, and I want you people to pay a very vivid attention, because whatever I will say here is what I will use throughout. There are some key things that I will say here, and you must keep it at the back of your head because we'll use it throughout. So, in this complex function, why is it important? Is for us to really see how it is important, we have to first of all show how the operation of taking a limit and finding a derivative for a particular function, which we all know in real variables. Like when we talk about real variables, we talk about variables like x, y, all these ones, they are real. Like x, y, z, these are all real variables. Then this our idea, how can we extend it to complex wall or complex plane? Now, when we talk about complex plane, is a mixture of real and the imaginary. We have the real section, we have the imaginary. So there is a way we will now use a function and match these two imaginaries. These two real function, right? We're going to get a complex function that relates two real variables, but one of the variables will be attached to a complex sign. So what I mean is we'll be using notation that are used for complex variables. Okay, most of the notation that I use for complex variables or complex operation, they are almost identical to the function that I also use in the real world. So there is nothing, if you know what we do in the real, when we talk about the real variables, it's the same thing that we'll be doing in the complex variable of complex world. Most of the notation that we use in the complex world is the same notation that we'll be using in the real world. And then in effect, the real variables that we are talking here is x. In that, if you want to take the x to the complex wall, they will replace that x with z. So, for example, if we say we have a function is equal to, let's say, 2x plus 1. Then with this function, we can say find the solution for this function f of x. When we say find the solution, we easily imply that you should look for the value of x such that when you put it in this function will become 0, right? So f of minus 1 all over 2 is a solution to this function. The same way we are taking minus 1 all over 2 is the same way we can do, say, find f of z. Okay? We can also do the same by saying f of z is equal to 2z plus 1, right? This is z. In this case, we can also do the same, that the solution will be when z is equal to minus half. So what we are saying is that whatever happened in the real world is similar approach that will happen in the complex world. Now, the interpretation of a function of a complex variable, the interpretation of a function which has complex variable and also has a complex operation is very, very different from the real case. Okay? So the way we use, the operation, the way we carry out the interpretation of the operation, they are not the same. So you will see that in the complex world, we are going to have different approaches, which is why we are studying this course. And in the real sense, a function of a complex variable is generally equal to two functions of real variables. What I mean is, if you take a particular function in a complex world, it must have two tails. It must have two real variables. One complex has two real variables. So why are we doing this? There are many situations in physics which are actually describe harmonic functions of real variables. And if we go into deep, we can see a typical equation that satisfies such. Okay, this equation is referred to as the Laplace equation. This equation, we use it to study the movement of waves. Okay, so for you to really get a very good understanding of this equation, then this complex variable is of significant importance. You need to know before this course. Maybe now will just be, I will not go too deep, but before you know this course, you should already understand what is referred to as polar and exponential form of a complex number. So when you go home after this course, try to use Google or use ChatGPT and ask the following question: what do you understand, or what is the meaning of polar and exponential form of a complex number? So that you should be familiar yourself with it, right? And
Yes,
then
sir.
the next thing that you should know, you should familiar yourself with trigonometry relations that has to do with a complex number. You should know all Riemann trigonometry relations, hyperbolic and logarithmic function, because we are using them in this complex very well. And then also, you should know more about partial derivative. You know what is partial derivative? I know all of you know. And then you'll be able to take limit. When we say take limit, you know what it is, right?